All right, hello everybody and welcome. I am Dr. Richardson and I'm excited to help you all learn Calculus 2 this semester. This is the second in the three-course calculus sequence. Today's lecture is really just kind of an introductory thing. I wanted to show you Canvas a little bit, talk a little bit about the structure of the course. It's just easier to kind of put things in a video to make it easier to digest. All of this stuff should be on the Canvas shell anyway. So if you don't see this or you skip through it or whatever, you should be able to find all of this information on Canvas as well. Let me pull up the slides and I will get started. Here we go. So welcome again. Today, what I want to do is go briefly over the orientation module. I'll talk about the lecture videos and the slides, for example, this one that you're looking at and watching right now. Go over the WebAssign homework. That's where we're going to be doing our homework for the course. Discussion posts, activities, and I'll explain why that's crossed out in a minute. We'll talk about quizzes. There are a few quizzes in this course, a few exams. We'll talk about Proctorio as well. I'll talk about Gradescope, which is what you're going to use to submit your exams. Then I want to talk a bit about some mathematical technology that you have access to for free as an SMC student. It's pretty cool. We'll talk about time management, and we actually have a weekly schedule template that my team and I came up with. So I wanted to share that with you and just talk to you about how you can manage your time for success. I'll tell you a little bit about myself, then give you some big questions that you should be asking all the time, not just in this course, but in all of your courses. Some big ideas about math, some important facts related to math. And then at the end, I want to talk a little bit about solving problems and then finish up with the growth mindset and metacognition. All right. So first, let's talk about the orientation module. When Canvas opens up, you can find the orientation module at the very, very top. It has all of the important course information that you need, so make sure to go through it in its entirety, okay? It's the very first thing you do on the first day. Go through that whole module in its entirety, watch everything, set everything up, and that's where you want to start. I'll show you in just a minute. But if you have a question, check the orientation module first because it's likely answered there, or check the syllabus because it might be answered there, all right? Another thing, we'll talk more about this in a minute, but you want to make sure to take the Proctorio practice quiz the first week. So this week, week one, okay? Let me pull up Canvas and I'll show you what it looks like. Where are you? Right here. One thing I'll say about this is set up for my fall 2025 class, but the layout should be virtually identical depending on what semester you're in. The structure shouldn't really be different, shouldn't change that much. But this orientation module that says start here, this is where you start, okay? So first day, you go right to this orientation module, you open it up, and you go through everything in that orientation module and it will explain a whole bunch of stuff, okay? Then the rest of the course is set up as weekly modules. The Gradescope link is just a link to Gradescope to make it easy. But then you'll see here, there's week one, week two, week three, week four, week five, week six, week seven, week eight, and so on. So the rest of the course is broken down by weeks. So that's what you're going to do, okay? Go to each week on that week, open it up, and then everything is right there. Some weeks, well, the first week always has a lot more, right? Because it's the first week, but that's the way that it'll go, okay? All right, let me get back to the slides because you're going to do that orientation module on your own on day one, week one. But let's see what's next. Oh yeah, lecture videos. So the lecture videos and the slides can be found in each weekly module on Canvas. The videos are actually posted to my YouTube channel. You can just subscribe to that playlist or whatever and watch them there. You can watch them at double speed. You can watch them at 1.5 speed. You can pause them, which you should. You can rewatch them. Just engage with them in whatever way works for you, okay? Whatever way works for you. The goal here is that you learn this content. So you got to figure out a way that's going to work for you. The average lecture video runtime is about 43 minutes, which is not too bad. And I actually list the lecture runtimes on the weekly schedule, which you can find on Canvas. In fact, let me pull it up right here. No, not that one. Where is it? This thing. And I'll show you what it looks like so you can kind of see what I'm talking about. Let me see. Where are you? Oh, you know what? Here, should do this real quick. Thanks for being patient. Just give me 1 minute. There we go. Is that still right? Yes. Okay. All right. So this is what the schedule looks like. You can find this on Canvas. Again, this is for fall 2025, but if this is a different semester that you're taking the course, the structure should be relatively the same, right? The dates might be different, but the breakdown should be pretty much the same. But what I want to draw your attention to is these two columns over here. These are the lecture run times. So you can use this to kind of budget your time for the week. This one doesn't have a runtime yet because I haven't finished recording it. I'm recording it right now. But for the rest of them, there's a time stamp there. So lecture 0001, that's basically a pre-calculus and calculus review lecture. It's the longest one of the whole course, okay? So a little bit of fair warning about that. The good news is it is broken into three sections. It's broken into pre-calculus, differential calculus, and integral calculus. Um, if you are already very comfortable with those things, you don't need to watch that lecture. There is a homework assignment associated with it, but a lot of it is stuff that you may have hopefully have already seen a little bit, like factoring, graphing, trigonometric functions, that kind of thing. But that's why that one is so long, because it's literally pre-calculus, differential calculus, and then a little bit of integral calculus. But 6.1 is like an hour long, 6.2 star is about 28 minutes long, and so on. At the bottom here, total number of hours is 25 for the whole semester, that is. Average is about 43. The shortest lecture is 11 minutes. The longest is the first one, surprisingly, or maybe not surprisingly. So you can kind of budget your time by looking at this, okay? Uh, Good way for you to keep track of how much time you have to spend on things. Okay, let me go back to this. Oh yeah, another thing, when you're watching the lectures, you should try to work out the examples when prompted. Again, you don't have to. I'm not going to track if you're doing it or not or anything like that, but it can help if you go through the examples. If you're low on time, you may not want to try to work them out on your own, but I will prompt you during the video. So what I usually do is this. When I want you to try something on your own, I will typically throw up the thinking emoji and I'll say something like, oh, think about this for a minute. And I will stare lovingly into the camera like Dora the Explorer does. Um, then I'll usually throw up this pair of emoji because I want you to say something out loud. And I'll repeat this a bunch, so I apologize. Basically, I want you to give yourself some verbal feedback. It really doesn't matter what you say. You don't have to say it to anybody if you're watching the video alone. It's okay to talk to yourself. It's not weird, trust me. I hope. No, it's not weird. It's not weird. But just say anything out loud to give your brain that audio feedback, because that can help you make sense of things. If you say something out loud, you're like, wait a minute, does that sound right? When I say it out loud, it sounds different in your head. You know what I mean? Okay, then I will usually throw up the writing emoji because that's when you want to just try to work it out on paper or your iPad or whatever you're using. Okay, so this is a way for you to engage with the lecture videos. You can just pause the video at this point, and then I usually will wait for about 5 or 10 seconds, and then I'll work out the problem in the video itself. Okay. Yeah, you can also read the slides. So the slides are available on Canvas. You can read them, and you can read the textbook as well. When you get WebAssign access, you get access to the ebook, and you can read along as well. Most of the examples that I use, I pull from the textbook, and the lectures are made to follow the textbook sections as well. All right. Okay. Now let's talk a little bit about WebAssign homework. So the homework for this course is on Cengage's WebAssign platform, and you access it through Canvas. There is actually, maybe I can show you real quick. Let me go back to Chrome for just a moment here. Basically like this. So you can either get to, oh, wait, well, okay, I guess you're going to go to it right here. You can find the homework problems in the weekly modules. For example, here's one right here, and you would just click this, and it will open up to that assignment in WebAssign, right? This one's actually locked because the course hasn't started, but that's how you would access the homework, all right? Then homework is due every Sunday night by midnight Pacific time. So be aware of daylight savings time. Here in California, we do observe daylight savings time, which can be kind of confusing when the clocks switch over. But the homework will take a lot of time, so don't put it off. One of the difficulties that students have with asynchronous courses is, at least what I've noticed, is they try to wait until the weekend to do all of the work. It's like they won't start on Monday or Tuesday or Wednesday. They might start on Friday, but then they realize like, oh my gosh, I have like 2 hours worth of lectures that I have to watch, and I've got, several hours worth of homework and stuff, and you just can't fit it all in a day or two. So don't put it off. Just try to keep pace, and we'll talk about that more in a minute. Now, a little note about Slingshot. So this semester, SMC is switching to a new textbook ordering system called Slingshot. Uh, Fair warning, I am not an expert about with how that works, but I can tell you this. If you already opted in to using Slingshot, then you should already have an access code for WebAssign and the ebook. So do not purchase them again. Don't purchase them a second time, okay? So if you opted in to Slingshot, you should already have paid for access to WebAssign and the ebook, okay? If you opted out of Slingshot, then you do not have access to the textbook or the ebook or WebAssign yet. But the way that you can get access is you can click one of the homework problems on Canvas, just like I did a moment ago, and then follow it from there. Uh, Another good thing is you'll have a 14-day grace period to purchase the resources here. So you can go ahead and get started on the homework right away. You don't need to have paid for WebAssign or the ebook to start doing the work. You can start doing it right away. But after 2 weeks, you will have had to pay for it. So this is one of the nice graces that Cengage gives us, which is kind of nice because if you decide, oh man, I'm going to have to drop this course, at least you didn't also drop X amount of money on the book and whatnot, right? Okay, but that's all I know about Slingshot. If you want more information about Slingshot, you'll have to go to SMC's website. You can ask a counselor. You can ask the bookstore. They know way more about it than I do. This is like a brand new thing. Okay. All right, let's talk a bit about the discussion posts. So every week there are two discussion posts due. There is one due by Thursday night at midnight and one due by Sunday night. And they're not as intensive as you might think. You basically just need to ask a question related to the content of the week by Thursday night and then answer a peer's question by Sunday night. So the questions can be kind of whatever you want, but please do try to make them somewhat meaningful. Don't ask random off topic questions like, "Hey, do you like broccoli?" or something like that. Just, you know, um, keep it focused on the material for that week. And you can ask more questions, right? So you don't really you can ask 20 questions if you want. Well, maybe 20 is a bit much, but you can ask your questions there and then please answer your peers' questions. This is a way for you to actually collaborate. Collaboration is a necessary part of mathematics. A lot of people think that mathematicians are these recluses that live in the woods and they bury their face in a book for 5 years and then magically they've come up with a new theorem. That is not at all what it's like, not at all. It's a highly collaborative process where you might sit there and think about something for a while, but then you got to go talk to somebody about it. So we would, mathematicians, we would go to a conference or go to our colleagues in the department and talk about it. So you should talk to each other too. And you can do that on the discussion posts. The basic idea, though, ask a question by Thursday night and answer a question by Sunday night. Those are the two posts, okay? Now, what I'm going to do is I'm going to go through and I'll start answering unanswered questions on Fridays and Mondays so that you don't have to wait too long if nobody's answering your question, okay? But that means that you don't want to wait too long to answer a peer's question because it may end up that you don't have any questions to answer. So don't wait. Like, again, don't hesitate. Don't put off all your work until the weekend. Ask a question early on during the week. Answer a question as soon as you can, and things will go really, really smoothly. Now, just in case you don't get a chance to respond to a peer's question, or you forget, or just something goes on that week and you're not able to make a post, that's okay. I'm going to drop 3 discussion posts at the end of the semester, your lowest three. So if you miss one or two or three, no worries, that won't be bad. But don't miss a whole bunch because that will be bad. All right, now I want to talk a little bit about activities, and you'll notice here that it's crossed off. So typically when I teach this course synchronously, either on ground or online, but synchronously, I will usually do group activities every single day. But this time for this asynchronous course, I didn't want to burden everybody with group work. But I still wanted to offer you access to those resources, okay? So what I did was I put the activities and the solutions in the weekly modules. Those are the activities that I would normally do if this were a synchronous course. Because yeah, they can be edifying and informative. Maybe I'll actually show you what I mean so you can see it right here. Okay, yeah, so like right here it says optional activities, and there's a PDF of the activity itself, and then the solutions. Okay, one thing I want to make clear: these are optional. You don't even have to look at any of them. They are not for extra credit. So don't burden yourself with trying to do these. These are just a resource for you to use. In the weekly discussion posts, you can ask about questions on the activities if you want. I encourage you to. If you want to meet up with some of your classmates, either on campus or online, maybe you can do some of these activity problems together. That's a great way to help you learn the material, okay? But these are not extra credit. They are totally optional. They are not due. They are not graded, nothing like that. The solutions will open up on Friday mornings because I want to give you all a chance to kind of like chew on them yourself and maybe even ask something about one of the questions in the discussion posts. All right. So that's a resource that's available to you if you would like to take advantage of it. Okay. Um, yeah, solutions will be locked until Fridays. So that way you have all the way through Thursday to ask questions about it. Okay, now let's talk about the quizzes. So there are four quizzes over the course of the semester. They occur about every 3 to 4 weeks. They're administered through WebAssign. They may or may not be proctored. Typically, they're not. The exams will be proctored, and I'll talk about that in a minute here. But those quizzes are closed notes, closed book. They're timed to help you get ready for the timed exams. All right. Again, this is one of those times where you've got to take ownership over your own education. Don't just cheat your way through the quiz because it's not proctored. Don't just like write all the answers in Chat GPT and just like fill it out. The point of that quiz is to help you understand how fast you need to go when you are on the exam. So for example, the first quiz, you have 45 minutes to do it. And I think there's like three, maybe four questions on there. So you should be able to do those 3 or 4 questions within 45 minutes. And if you find that you struggle with that time constraint, then you're going to have to study a little bit more and try to make deeper sense of the material so that you can perform a little bit faster on the exam. Another note, quizzes do not occur on exam weeks. So there will never be a week where you have both a quiz and an exam due. Okay? Just way too much if that's the case, right? Okay, so now let's talk about the exams. There are three timed closed notes, closed books exams, and a cumulative final exam. So there's like three midterms and a final, okay? The exams will open up on Canvas on Thursdays and they will close on Sunday nights, Pacific time, once again. So basically, you will have Thursday, Friday, Saturday, and Sunday to do the exams, okay? What I will do is on Mondays, I usually post an announcement on Mondays every week, Monday of every week, and I'll let you know what to expect on the exam so that you can focus your studies. And I'll be relatively explicit with what is on the exam. I'll say, there's a question like this, there's a question like that. You need to be able to do this on the exam. You need to be able to do that on the exam. But I won't tell you the exact problems. I won't say like the question is going to look exactly like question number 4 on homework 6.2. I won't do that, but I will say something like you got to be able to do this. Now, the exams are proctored using Proctorio, which is an online proctoring software, and that's what I want to talk about now. So, yes, Proctorio is an online proctoring software, and the thing that I need to make very clear right now and be very upfront about is you will be recorded during the exams, okay? So this tends to kind of confuse students a little bit in the beginning, or it might make you feel a little bit nervous. Don't worry about it. Basically treat it like a surveillance camera, and you're basically gonna set up your camera and your microphone to record you while you take the exam. And I've got a whole video that shows you how to set it up. That's linked here, linked several times on Canvas, and I'll show you in a minute. Yeah, you can see the orientation module for details. What I want you to do is I want you to take the Proctorio practice quiz in week 1 so you can see what it is like. You will need to install a Chrome extension, and you should be prepared to troubleshoot tech issues. For example, In the Proctorio practice quiz, it will actually have you practice what it is like to get kicked out of the exam. So if there's a technical issue, again, Proctorio is a proctoring software, so it may kick you out of the exam. Now, I'm not the one who's kicking you out of the exam. I'm not the one who's proctoring it. So when you use Proctorio and you get kicked out, you have to contact Proctorio, and they've got agents that are on call 24/7, and they will let you back into the exam. The practice quiz will walk you through all of that, okay? But generally speaking, I'll just say this for real, you can just treat it like it's a surveillance camera. Don't worry, like I'm not sitting there staring at the video, watching you while you take it or anything. What it's doing is it's making a recording of you taking the exam, okay? And I've got a whole protocol for how you're going to submit your exams. And that video that I'll show you the link to in a minute goes through all the details and shows you an example of exactly how you're going to do it, okay? Now, also, this being said, I want to say this. Please do not cheat. Please don't cheat. We need Proctorio because the reality is people will cheat. And if we didn't use Proctorio, most people would cheat. It's something that we have explored and we've discovered over many years of using the software and comparing to other departments that don't use the software. It's unfortunate, but the reality is people will cheat. So I am begging you, please do not cheat because it just makes everybody's life miserable when you do that. You will get caught, and if you get caught, then I have to give you an F in the course, and I have to report you to student judicial affairs, and it's a big mess. Everybody hates it. It makes everybody upset. So just please don't cheat. That includes sharing information about the exam, sharing your solutions, telling people what's on the exam. All of that is cheating. So please, please don't do that. I'm like begging you. I don't want to have to go through it again. I've gone through it just so many times, usually once or twice a semester. It's just a headache. So please, observe academic integrity. Be truthful to yourself, be truthful to me, be truthful to the institution, and be truthful to the world, please. Please just don't cheat, okay? Okay, that's my appeal there. Now, let's talk about Gradescope. So, Gradescope is an online assessment platform, and what it does is it just makes it easy for me to manage all of your submissions and for you to see my feedback. So, that's actually where you're going to submit your work for the exams. And again, there's a video that will show you how to do all that. So, you will receive an email from Gradescope on day one inviting you to make a Gradescope account and to log into our Gradescope course. Now, you will not receive that email until day one because students are still dropping and adding the course even past day one. But if you are enrolled in the course on day one, you will get an email from Gradescope asking you to join the Gradescope course. For real, check your spam folder. The email is there if you are enrolled in the course. You don't need an access code. There's no code that you enter. It is synced with our Canvas course and they're literally connected. So if you are enrolled and you are on the course roster, you will get an email from Gradescope on day one, because that's what I'm going to do on day one. I'm going to go, okay, bink, sync the roster, and everybody gets an email. Okay. Now, feedback and point assignments on exams will be given on Gradescope. The total value will get transferred over to Canvas. But if you want to know, like, why did I miss that problem? What feedback is my professor giving me? That's going to be on Gradescope. If you've already used Gradescope, you've already got a Gradescope account, cool. If you've taken me before, I use Gradescope in all my classes, so you can use the same account and it'll work. But that's where you're going to see all my feedback and the rubrics for the exams and the point breakdowns. Okay. All right. Now, here is the setup for exams. This video is linked many times throughout the course, but watch this video and it will show you how to set up your camera for the exams and how to submit your work to Gradescope. It is essentially what you need to do. The video I recorded for my online trigonometry course, but the protocol is identical for this course as well. So watch that video. It's in the orientation module. It is linked on the Proctorio practice quiz. I will link it in the weekly announcements that I send out, but set it up this way so that you can figure it out and get over all the stuff and it'll be fine, okay? Now, some cool news. Some mathematical technology that you have access to. So, guess what? Every SMC student has free access to Wolfram Mathematica and Wolfram Alpha Pro. Okay, Wolfram Alpha Pro. This is something that me and the chair of the department lobbied for a couple years ago, and we were able to secure funding for every SMC student to have access to this software. If you've ever used Wolfram Alpha, that's basically like the online version of Mathematica, and it can solve things, right? It's a computer algebra system. Well, if you've ever used that, what I'm telling you now is you have access to the pro version of it. Okay. As an SMC student, you have access to the pro version and you have access to the much more powerful desktop version of that, which is called Mathematica. Um, Mathematica is a very, very popular mathematical technology tool. I use it in my own research. My colleagues use it in their research. It's really, really powerful. It's got a computer algebra system. It's cool. All right. So I encourage you to use it. It is available to you for free. You might as well take advantage of it, right? So, how do you get access to it? You navigate to this link or navigate to that site and enter your SMC email address to get access. It's got to be your SMC email address. It cannot be your personal email address. If you try to use your personal email address, you will not get access. It won't let you. Okay. Another note for those of you that want to download Mathematica to your computer, which I recommend because your computer is way more powerful than trying to send information across the internet and back, especially when it requires a lot of computations, like detailed computations. It's easier to do it on your computer, like on your actual computer. But the documentation for Mathematica is very well organized online. So if you want to save hard drive space on your computer, you don't need to download the documentation. Literally, what I do when I need to read up about a command for Mathematica, I just go to Google and I type Mathematica and the command, and the first hit is always the documentation for it. So up to you, okay? Um, this is, I kind of already said this stuff before. It's a Wolfram Alpha is an online computational knowledge engine. It's got a very, very powerful computer algebra system. Oh, it also has a GPT interface if you're interested in using that. If you use Chat GPT or something, Mathematica has a GPT interface. This I said, and this I said as well. Yeah, that's it. And then another piece of software that I want to just bring everyone's attention to is Desmos. Desmos is just an online website that you can go to. Their graphing calculator is really, really good. It's very intuitive. It's easy to use. So I highly recommend it, and I like to use it in my slides, the lectures, things like that. So if you ever need to make a quick, high quality graph, or just verify that a graph you have is correct, then Desmos is a good place to go. All right. It's also got a mobile app and it can do computations as well. So check it out. All right, now let's talk a little bit about time management. So shifting a little more to some soft skills and just how are you going to succeed in college and in life. Time management is one of them. Okay, it's one of the most important skills you can develop in college. It's necessary for success in school and life. So I want you to work on your time management this semester. Yeah, it's also one of the clearest and most direct ways you can exert control over your life. You can control how you spend your time, okay? Time is like the only currency we really get in this life. So spend it wisely, figure out how you want to spend it, budget it, and then spend away, okay? Now, the general rule in college is that for each course you take, you should plan to spend 2 hours studying outside of that class for every 1 hour that you spend in class, okay? So that means for this course, it's 5 units or 5 hours of arranged time. So that means you should expect to spend about 15 hours a week on this course alone. So let me kind of explain this. If this course were synchronous, we would spend 5 hours a week synchronously interacting with each other. Then you would spend double that amount of time outside of class on the course. So that's 10 more hours, okay? Oh, hold on one second. One second. There we go. Sorry about that. So basically, normally you would spend 5 hours in class and then 10 hours outside of class. But since this is an asynchronous course, all of that is kind of the same. So you're going to spend 15 hours a week on this course alone. That includes watching the lectures, doing the homework, studying, taking a quiz if you need to, taking an exam if you need to. That's how much time you're going to spend on this course alone. All right. And then similarly for your other courses. So What I did here was I put together a generic weekly schedule template. You can find it in the orientation module, and I'm going to show it to you right now. And it's going to help you develop a realistic schedule for your school, your work, and your life commitments for the next 16 weeks. This is something that I did when I got into grad school. I had a ton of responsibilities. I had family, kids. I was working two jobs, and I was going to grad school, right? So I needed to budget my time rigorously. So let me pull it up here so you can kind of see that. Hold on a second. There we go. And it's right here. And let me show you what the template looks like. It basically looks like this. And again, this is just for this semester. If you're watching this in a different semester, it would be roughly the same. The rest of this would be the same, but this date might be different. So for this semester, fall 2025, this is what it will look like. And all it is the 7 days of the week across the top. Each one of those corresponds to a column. And then what I've done is I've written the hours of the day parsed out by half-hour chunks, okay? From 4 a.m. all the way to 3:30 a.m. It's a full day, right? And then over here, I have some suggested uh, time blocks. So there's sleep. You're gonna have to sleep. There's transitions and hygiene. You know, if you need to like take a shower, go to the bathroom, brush your hair. There's commute. There's exercise. You really, really should exercise. Take my word for it. You will thank yourself in the future. You got to commit a little bit of time to exercise at least, okay? Class time when you're going to be in class, work when you're going to be at work, study time when you're going to be studying, friends and family, budget time with your friends and family. Be like, okay, I'm going to try to schedule this time to hang out with my friend. I'm going to schedule this time to go say hi to my mom or something like that. Schedule your meal times. You're going to have to eat. So think about how long it takes you to eat. Think about when you need to eat and schedule it in there. And then also me time, basically time that's just for you, where you don't have to do work, you don't have to do studying, you don't have to deal with any other people. You don't have to commute or exercise. That's me time. And you can plan all that stuff. So what I want you to do is you can go in here and color code these blocks. You know, maybe exercise I'll make, oh, I don't know, green or something, right? And then you can basically say, okay, maybe what I'll do is I'll exercise on Mondays at 8:30 and Wednesdays at 8:30 and Fridays at 8:30. And then what I like to do is I like to use black for sleep. So budget your sleep. Figure out how much time you actually do need to sleep. You will thank yourself later if you allow yourself to sleep enough, okay? Sleep is a necessary part of life. Give it to yourself, okay? So I know I would probably be asleep from like here to here. So maybe I'll paint that black. There you go. That's sleep. So sleep is black. There we go. And then you can keep going. You know, maybe you've got a class from, oh, I don't know. Maybe you got a class from about 12:30 to 2. You could make that, I don't know what color we can make class time pink or something. Okay, so that's class time. Right. Oh, and then you've got a commute to class. Well, maybe you've got kind of a long commute. We'll make the commute red. You can say this is like commute time. But basically, hey, there we go. Basically, go in and schedule your time, budget your time, right? And again, it goes all the way through the full 24-hour period every day. So maybe you go to bed at, geez, when did this say? 7:30. I usually need about 7.5 hours of sleep. So if I was able to get up at 7:30, I would probably go to bed at like 12. There we go. So that's like blacked out. So now I can really see like how much time I have in that day. Right here, this is transitions and hygiene, right? This is like, be honest with yourself. Once you get up, you're gonna have to go to the bathroom. Maybe you need to have some coffee. Maybe you need to just like chill and just stare at the wall or something. Like you can budget that time in there. Transitions, maybe I'll make it gray or something. Here we go, like gray. Okay, so make that gray. That's my transition time. I got half an hour from when I wake up to when I'm going to go exercise. Okay, so you can use this to help budget your time, all right? And you can find this in the orientation module, but I highly recommend it. I mean, it changed my life once I finally did this, and I was able to do so much more than I thought I could. All right, all right. That's my spiel about that. Back to the slides. Oh yeah, fill it out, update it weekly as needed, and then stick to the schedule for this semester. And remember, this is important. Semesters end. Okay, this is not forever. You don't need to live this life and live that schedule forever. It's 16 weeks. So the schedule commitment is temporary. Set the schedule, stick to it for 16 weeks, and then take a break. That's what the breaks are for in college, okay? You don't need to take a class in the winter. You don't need to take a class in the summer. You can take a break and just go explore life, go explore reality, okay? If you want, you can talk to me about time management. I have become an expert at it and I can help you work out the kinks. In my experience, the kinks are usually related to transitions and giving yourself enough time to transition between events, that kind of thing. Okay, so weekly schedule. You can use the template for this too. Here's your weekly schedule for Calculus 2. You're going to have to watch 2 to 3 lectures a week. The average is about 2.2 lectures. Um, the length varies, but like I said, you can look up the length on the schedule. You're going to have to do 2 to 3 homework assignments each week. Again, the length varies, it depends. You're going to have to make 2 discussion posts each week, and you may possibly have to take a quiz or an exam during a week, but not both. All right. And then I just want you to keep pace. Okay. You got to keep pace, schedule your time, budget your time, stick to the schedule, and keep pace. I always tell my students that semesters are like marathons. They are long and you need to pace yourself, okay? Don't run real fast in the beginning and then you can't finish, you burn out at like, midway through the semester. Pace yourself, okay? Pace yourself. Yeah, pace yourself. Okay, now shifting gears a little bit, I just wanted to introduce myself a little more now that we've talked about that stuff. Your professor, that's me. My name is Adam Richardson. I got my bachelor's of science in applied mathematics. I got my master's of science in pure mathematics, and I got my PhD in theoretical mathematics. My trajectory is unusual. I used to be a writer, then I was a filmmaker, and now I'm a mathematician. I still do math research. My most recent result I found, at the end of last year, and I spoke about it just this past May at the AMS Spring Western Sectional Meeting. My field of research is fractal geometry and complex analysis to a certain degree. What I study are space filling curves and the complex dimensions associated with those space filling curves. If you ever catch me on campus, maybe we can talk about it sometime. But obviously, I could talk for many, many hours about that. About my own research, so I will stop doing that right now. One thing I want you to know is I actually really hated math in high school. I did not like math at all in high school. I started to love math when I got into college because I had 1 or 2 really good professors that really turned my whole perspective of math around. And I just realized that what I had thought math was not correct. And they showed me like, oh no, math is actually about this. Math is supposed to make sense. Math is a creative process. It's less rigid than you might think. It's really, really fun. And then my whole life changed after I made that realization. So I love math so much now that I've dedicated my life to learning it still and helping others love it too. So I hope I can help you learn to love it more. Maybe you already love it, great. If not, I hope I can help you learn to love it at least a little bit. Okay, so let's talk about some big questions that you need to be asking all the time. And I mean all the time, every class, anytime you're learning something, anytime you're doing anything, you need to be asking these questions, okay? First, why am I learning this? Okay, why should I care about this? You may not think that you are owed answers to those questions, but you are. You deserve answers to those questions. You should be asking, why do I care about this? What's the point? Like, why am I going to suffer through learning all of this stuff? What is the reason for it? Is there a reason? You should ask those questions. This one, when will I use this in my STEM career? You want to think beyond college too, right? You don't want to think like, oh, I'm just going to use this in the next math class. You want to ask yourself, when am I going to use that in my career? What is the career relevance to this? What is the life relevance to this idea? Okay. This is a big one. What is the intuition for this idea? Mathematics can be very, very intuitive. And one of the things that blew me away when I started doing research math was just how much intuition guided research in doing research level math. It's like you have this intuition for what should happen or what you kind of feel like will happen, and then you investigate it in that context. and then you apply rigor to it, and you see if you can make the mathematics rigorous, and then you'll really know if your intuition is right or not. That's like the fun part. Um, you want to ask yourself, does this make sense? Math is supposed to make sense. You want to ask, when do I lose the feeling of understanding? So, this is one of those things where I can't tell when you lose the feeling of understanding. Only you can. And everybody that's ever done math has experienced this. You know, it's like maybe you're sitting there listening to a lecture, everything's going all right. You're like, yeah, got it. And then all of a sudden you're like, wait, what? I have no idea what just happened or how they got to that point. That's when you need to recognize that you lost the feeling of understanding. And that's when you want to ask questions. You want to reach out to your peers. You want to reach out to me. You want to go to the math lab and talk to a tutor. And you want to say, wait a minute, how does this work? You want to practice pinpointing those moments. All right. So, some big ideas about math, because I think this is a good question to ask. What does mathematical understanding look like? You know, like how can you tell if you really understand the math? Well, one hallmark of mathematical understanding is the ability to justify in a way appropriate to the student's mathematical maturity why a particular mathematical statement is true or where a mathematical rule comes from. So that is what I would call authentic mathematical knowledge. You should know why something is happening the way it is, and you should be able to justify it in a way that's appropriate to your level of mathematical maturity. If you're already at the calculus level, you have a great deal of mathematical maturity. You may not believe it, but you really do. So when we come to these conclusions in this class or we learn these theorems, you really want to understand why. That doesn't mean you need to be able to regurgitate a proof of like a theorem, but you should kind of get why the theorem is true. And you should kind of be able to say, okay, yeah, I at least feel like that could be right. And then that's when the rigorous mathematics comes in, because it's like, okay, well, that's how we feel. Can we prove it? And that's the rigorous part, okay? Some big ideas. I said this once already, but demand intuition. You should demand intuition. Appeal to basic counting if you can. A lot of stuff, see if you can just count something to get the answer. Um, Always try to imagine a picture if you can. Okay, always try. There is an intimate connection between algebra and geometry. You should always try to imagine a picture. Pictures can help guide you. They can fuel your intuition, and they can help point out where the rigor should occur. Okay. Now, there's another thing. There are two parts to mathematics. There's obviously more, but these are two distinct parts. There are the ideas in our mind that we want to talk about with other people, and then there are the literal symbols we use to write things down, to represent those ideas. Those are two different aspects to mathematics, okay? Again, the things that we're thinking about, and then the literal symbols we are using to communicate those ideas. And what you want to do is you want to get strong in both. In my experience, students tend to be strong in one or the other. So, for example, students might be really good at like understanding what's going on. They've got a good intuition, they're making sense of things, but they have trouble manipulating the symbols. That's okay. Or some students will be the opposite. They will be able to manipulate the symbols very well. Like, oh man, they can solve an equation in all sorts of cool ways. They love doing that, but they may not know what's going on when they're doing those operations. They may not know why they're doing them or what they're doing when they solve. That's this part right there. So, one of my goals is to help you balance out those two skills and then elevate them, because that's what you need to be successful in math, a balance of those two abilities. Okay. Now, we got to talk a little bit about the emotional component, especially in Calc 2. Um, Math is not easy and it involves a lot of frustration, okay? Acknowledging your feelings about the process of learning and doing math is important and it's necessary. Don't feel bad for getting upset with math or feeling that you're lost. That's actually part of the process of learning and doing math. Learning how to cope with those emotions is part of learning how to do math. And I mean, I can't tell you how many times this scenario has happened to me where I'll be working on a math problem, trying to solve it. I'm trying all these different approaches. It's not working. It's going nowhere. I've spent 3 hours on it. I'm getting frustrated. And then finally, I'm just like, ugh, I push it away. And then I go to bed. And then the next morning, when I wake up, suddenly it clicks. And I'm like, oh, whoa. I'm like, that's what I was missing. my brain just needed a rest. Okay. So sometimes you just need to go to sleep, take a rest, and then revisit the problem. And you might be surprised at how quickly you just suddenly get it, where you're like, oh, that's what it is. Okay. Now, I like this quote from Andrew Wiles. He's a very famous mathematician. His rise to fame came when he proved a very old, unproven theorem called Fermat's last theorem. He proved it in the mid 90s, but it had been unsolved for something like 260 or 270 years. But he had this to say about math. So I really like this quote. To do math, people tend to believe that there's something you're born with, and either you have it or you don't. But that's not really the experience of mathematicians. We all find it difficult. It's not that we're any different from someone who struggles with math problems in the third grade. We're just prepared to handle that struggle on a larger scale. We've built up resistance to those setbacks. Okay. That was my experience. Again, like I did not like math when I was younger. I didn't think I had the math gene, that kind of thing. But I'm telling you, that's not the reality. You can do this. You can definitely do math. If there's one thing I know you can do in this life, it's math. Okay. So some other important facts here. This is a question students ask me a lot, so I want to clear this up. There is no highest math class. There's no end. There's no final math class that you can ever take. Really, it's more like a rabbit hole, and you just decide when you want to stop going down the rabbit hole. You can go on forever if you want. You can keep studying math forever and ever and ever for your whole life, and it can be really fun. So, I like to include these photos of another very famous mathematician, Alexander Grothendieck. He was the father of algebraic geometry, and here he is when he's in college. Here he is a little bit older. Here he is when he's older than that, and then here he is shortly before he died when he became Gandalf. Just kidding. But he studied math his entire life and was creating new mathematics his entire life, like all the way from college until death. There is no highest math class, there is no end. You can keep going as long as you want. And mathematicians like myself, we just keep going because it's just really fun. We get absorbed in it and soaked into it, and it's just fun. It's really fun. So other things, yeah, there's no highest math class. This is an important thing, and I need you to take this to heart. And the next bullet point here: math is designed to be understood by anyone and everyone. That's its whole purpose, is that anybody and everybody can understand it, okay? So if something in math doesn't make sense, it's usually because it's not being explained well enough. And that's a fact, okay? Now, who can explain it the best? That just depends on who you are. So this is why I want you to collaborate with your peers. I may not be able to explain something as well as one of your peers would be able to. One of your peers might be like, oh, I can explain that. This is what's happening, yada, yada, yada. And that might click better than me trying to explain it, okay? That's why you want to collaborate and talk to others. But if it doesn't make sense, it's usually because it's not being explained well enough. All right? Um, Now, last bit here. Yeah, I am confident that you can get to the point where you can understand any mathematical idea in an intuitive and meaningful way. All right. Take that to heart. You can do this. You can understand these things and make sense of them. I promise you that. Now, another point, important point here, you are not a computer, okay? You're not a computer. Don't try to be a computer. We've already got computers. Don't restrict your mathematical understanding to just being able to do calculations, all right? You need to emphasize conceptual knowledge and intuition. We've already got machines. We've got machines to do the calculations, even algebra, as we're going to see in this course. Like, we'll talk about that, but we have machines to do that kind of thing, okay? In the future, your job will often involve translating an idea into a form that a computer can handle or a computer can understand. This is often what we call coding, all right? So now, I want to give you all this piece of advice. All right. If you're a STEM major, you must learn a programming language, something like Python or Java or C plus or C sharp, something like that. Um, I'm not saying you need to learn it in this class. I'm not saying you've got 16 weeks to learn how to code in Python. What I'm saying is, over the course of your undergraduate degree program, you've got to learn how to code, okay? Even if your counselor says, oh, no, that's not a requirement of your degree, trust me, it should be. It's one of the best pieces of advice I got. I will admit, like, I one of the reasons I switched from applied to pure math is because I didn't like the coding and I didn't want to have to code. But then when I got into my PhD, I was like, oh, yeah, it's just necessary. Like, it's necessary to be able to translate your ideas into a form that a computer can understand. Like, it's a requirement of modern math and science. So do yourself a favor, learn how to code over the course of your undergraduate degree, and when you graduate, you will be way more marketable than somebody who didn't learn how to code. Okay? Yes. All right. So now I want to talk a little bit about solving problems. We're almost done here. So this is from a 1988 study, so it's getting a bit old now. How can students approach a problem? And this study, conducted by math ed specialists Judith and Larry Souter with elementary school students, found that students used the following 7 strategies. And you might find this pretty interesting. Oh, there it is. Oh, hold on one second. One sec. There you sorry about that. So they did this. This might sound familiar. One, find the numbers in the problem and just do something to them, usually addition. Two, guess at the operation to be used, perhaps based on what's most recently been studied. Three, let the numbers tell you what to do. So, for example, one student said, if it's like 78 and maybe 54, then I'd probably either add or multiply. But if the numbers are 78 and 3, it looks like a division because of the size of the numbers. Four, try all the operations and just choose the most reasonable answer. Five, look for key words and then decide on which operation to use. Hang on a second again. All right, there we go. Six, narrow the choices based on the size of the expected answer, the expected size of the answer. Or seven, choose an operation or relation based on making sense of the problem. Okay, so here's one of those times where I want you to just ponder these for a moment. Okay. And maybe I'll do this. Say something out loud about how you feel about those techniques. Anything out loud. Doesn't have to be you can talk to yourself. Just say something out loud to give your brain that feedback. All right. Okay. And now let's talk about it for a sec. So you might notice that, well, for one, there's this. I really should put this as the first bullet. We've all used these methods before, right? You know you've done these kinds of things in the past. If you've ever taken a standardized test, you know that you've done this kind of thing in the past. But only one method involved actually understanding the problem, okay? And methods 1 to 6 involved some degree of what I call trying to defeat the assessment. And what that means is it's like it's a mindset shift. What happens is a student inadvertently restructures their problem solving attempt to one that sees the assessment itself as the problem to be solved instead of the question that's being asked of them. So it's one of those times where you're like, okay, I don't know what to do here, but what is the teacher trying to get me to answer? Like maybe they want me to do this, or oh yeah, we were just talking about that yesterday, so this must be their way of giving me a clue that I should do it this way. Don't do that. That's trying to defeat the assessment. So just take the problems as they are presented and solve the math problems. Don't try to read my mind or get into my psyche and figure out what's going on in the background. Don't do that. That's trying to defeat the assessment. Don't defeat the assessment, just take the assessment, all right? Yeah, those approaches are antithetical to the goal of education and they don't result in authentic learning. Those techniques they're not doing authentic mathematics, and that's what you want to learn. You're in math class, in this math class to learn math, not how to defeat the assessments that I give you. All right. So that's one thing to keep in mind. Um, Now, I want to talk for a minute about the growth mindset. I think many of you have heard about this before. If you, excuse me, if you have, great. If you've not, I'll tell you a little bit about it right now. But in educational theory, a lot of research has been conducted relating to fixed mindsets and growth mindsets. And put succinctly, a person who has a fixed mindset believes that qualities like intelligence and talent are fixed traits that you're born with or you're not. Whereas a person who has a growth mindset does not believe that. So, for example, a person with a fixed mindset might think and say, oh, I've never been good at math because I'm just not smart enough, or I don't have the math gene, right? That was me. That was me all the way up through high school. Through high school. But a person with a growth mindset understands that qualities like talent and intelligence, those can be developed immensely through dedication and hard work. And I'm a perfect example of that. There is no math gene. Like I wasn't born with or without a math gene. I just figured out how to make sense of it through the guidance of some helpful instructors and my peers. So I grew that ability. That love for math that I have is something that grew. It's not something that I just like came out of the womb with and I was like, oh my gosh, I love math. No, yeah, it's you learn it and you learn to love it. It's really cool. So one of my goals is to help you break out of the fixed mindset if you have one and develop a growth mindset. Okay. All right, now last thing to talk about is metacognition. This is all kind of related. So I'm not sure if you've heard of metacognition. If you have, great. If not, then I'm excited to tell you about it right now. So metacognition is just awareness and understanding of one's own thought processes. This is basically thinking about how you think, thinking about the way your brain works, thinking about how your brain operates. That's metacognition, okay? This is another one of those skills that is critical for success in college and in life, all right? Thinking about the way you think, thinking about your needs. This really just requires looking inward and being truthful with yourself, okay? You don't need to lie to yourself. Like you have control over yourself. You can exert a great degree of control over yourself. So, try to control your mind, try to control your body, look inward, think honestly about how you think and are, and plan for yourself. You're not wrong and you're not bad for needing things. If you need a thing, just say, "Oh, I need that thing." Oh, hey, and you know what? You can put it into that weekly schedule. You can be like, "You know what? Here's a great example. You're like, you know what? I can't wake up right when my alarm goes off. I need to hit snooze a couple of times. Great. Then plan for yourself. Plan for yourself. Give yourself the time to hit snooze a few times, okay? That's all right. That's totally all right. Just allow yourself to do it. I like to think of it like this. Set up the future so that you can comfortably walk through it when it becomes the present, right? So here's the future over here. Human beings, the only existence we experience is the present, this moment right now. That's the only experience we get. So the future is over here. The future at some point is going to become the present. Plan for it. Look ahead and think, okay, at some point that moment is going to come right here and I'm going to experience it. So if you look ahead a little bit, you look forward a little bit, you can start setting things up now so that when the future becomes the present, you'll be ready for it. Another example I like to use is like an automatic coffee machine. I like to have a cup of coffee in the morning, but I found out that I don't like having to make the coffee when I get up in the morning. I'm tired, you know? I don't want to sit there and like measure things right when I wake up and like, wait for it to brew. So what did I do? I bought an automatic coffee maker. And now what I do is I set up the coffee machine the night before and then I go to sleep. And then when that time becomes the present, the coffee is already waiting for me. Yay. There you go. So that's what I'm talking about. Okay. All right. On that note, I guess I'll just say, welcome to Calculus 2, everybody. Here we go. Canvas will open up very soon if it's not open up already. I'm really excited to talk to you all a little bit. Um, Study, pace yourself, and thank you all for watching. And I will see you around. Enjoy, everybody.